Hi everyone, in this video we're going to go through how to get the equation of a circular function or the rule of a circular function given either the graph or information about the graph. So from previous sections we have learned what a sine and a cosine are like. So let me just quickly do a sketch up here. So just your basic sine and cosine graphs go from -1 to 1 and have a period of 2 pi. So when we're sketching it, we usually put our split our period into 4. So that's pi on 2 and 3 pi on 2. Okay, so your sine graph always starts at 0. Well, your basic sine graph, okay, without any transformations. Goes up to 1 and then down through pi, then down, turns at 3 pi on 2 and back to 2 pi. Now your cosine graph starts at 1, crosses at pi on 2, has a turning point at pi, that's a terrible graph, crosses the x-axis at 3 pi on 2 and then finishes back up at 1. So my poor drawing shows that they don't really look the same, but if I was to continue, they do look the same, all right, and you should know that by now. So your sine graph and your cosine graph can actually be the same equation. Well, not the same equation, but the two equations can represent the same graph. And it just depends on the transformations that have occurred. All right, so let's just go back to, actually I might just write this here. So this is our cos graph. And noisy plane up above. It's our sine graph, okay, in green. So I haven't had any transformations. Amplitude is still 1, period is 2 pi. Okay, but they can all change. So from, I don't know which section it was, but we did go through the period. So your period is not n, it's 2 pi divided by n. So n being the coefficient of t. A few more n's than I expected. Your amplitude is a. Okay, so for the two graphs I drew, your amplitude was 1, but the value of a just stretches that graph. So whatever a is your amplitude. Now it's not negative. If you've got a negative in front of the a, your amplitude is not negative. Your amplitude is always positive. The negative just means it's been reflected. All right, with the sine and cosine graph, your maximum domain is always R unless you've been restricted. So you can see here my sine graph, if we're just stopping there, my domain is from 0 to 2 pi, and my cosine graph would be from 0 to 4 pi, even though I haven't extended, but I've basically gone 2 cycles. The range is -a to a, so remember that is based on your amplitude. Unless you had a vertical translation, then that's going to change your range because your graph is either going up or down. Okay, now from another section in chapter 6, we looked at the transformations. So remember, a is your amplitude. Okay, so that kind of just stretches your graph. N, see where n is outside the bracket, so make sure you always take n outside your brackets, and we use that to calculate the period. Now, inside the brackets, we've got plus or minus epsilon, so just another Greek letter, and that just means we're going left or right, so there it is there. And then plus or minus b, so b being your vertical translation. Okay, so similar to other functions, really. Okay, so you need to be familiar with all that to be able to get your rule. Okay, so if we look at question 1, we've got a function ft is equal to a sine nt. So they've used capital A here. It doesn't matter. You could use any letter you like, whether it's capital or lowercase. Usually we tend to use n for to help us calculate the period though. All right, the amplitude is 4 and our period is 6. We've got to find a and n and then we've got to sketch it. So sketching is a bit time consuming. We might not do all of them. Okay, so this one's pretty basic. And I mean basic because they've told us what the amplitude is. So A is 4. Now your period is 6. So that means 2 pi on n is equal to 6. So just make sure you don't say n is 6. 2 pi on n is 6, and then you've got to solve for n. So just changing spots with the n and the 6. So n is equal to pi. Oops, not on 6, on 3. Sorry. So your equation, or your function, is f of t is equal to 4 sine pi on 3t. Okay, so we've worked out n. N is not 6. Okay, you do have to go ahead and do n. All right, so sketching. Let's just do a rough sketch. All right, so that's t, and up here is f of t, and we're going from 4 to -4. We haven't had any vertical translations. We haven't had any horizontal ones either, so it's not going to be a difficult one to draw. All right, our period is going up to 6, and we also have to do our domain is up to 6 as well. So when we do our scales, before we sketch our graph, it's always important to think about, well, if your period is 6, put that at the end, divide it by 2, so there's 3, and then divide it again. So we're going to have 3 on 2, and 9 on 2. All right, so it is a sine graph, so we've got to start at 0. So sine graphs always start at 0 unless you've had a different, if you've had a horizontal translation, so if it's moved left or right. Okay, we cross the axes at these main points, so 0, 3, and 6, so halfway and then the full period, and our maximum is up there at 3 on 2, x equals 3 on 2, and the minimum at 9 on 2. And then you just got to join the dots. All right, so there's the graph of 4 sine pi on 3t. All right, I'm going to skip B and do C. So we've got an example of a cosine graph as well. Okay, so we've got amplitude is 3, so A is equal to 3. Your period is 5, so 2 pi on n is equal to 5. So n is equal to 2 pi on 5. So your function is ft equals 3 cos 2 pi on 5t. All right, so again, we just do exactly the same thing. Now, if your domain was longer, you would just have to make your x-axis longer. So we're going from -3 to 3 because that's our amplitude, and we are going to 5. So why they always make me think about fractions. So 2.5. All right, so I just had to pause to get them. So 5 on 2 is halfway, then half of that is 5 on 4, and that can help you with your scale. So if we thought about our scale with the same denominator of 4, it'd be 5 on 4, 10 on 4, which is the same as 5 on 2, 15 on 4, which we can't simplify, and then 20 on 4, which is 5. So yeah, cosine graph starts, one different color, starts up here at 3. So remember your original cosine graph starts at 1, but because our amplitude is 3, it starts at 3. Crosses the x-axis here at 5 on 4, then goes down to 5 on 2, up to 15 on 4, and then ends at 5. So we go, whoops, well, that's terrible, but there it is. All right, let's move on to question 2. So the graph shown below is in the form a cos nt. All right, so this isn't a hard one. So A is clearly 3. Amplitude is always the easiest one to see, okay, because it's just whatever is on the y-axis. Now your period is a little bit harder. So for this one, our period is however long it takes to do one full circle. So this is a cosine graph. So going from, I might just highlight it, 3 down to here is half your circle, and then another one is the other half of the circle. So we're going around the unit circle. Okay, so that's what it looks like as a graph. So our period is 8. So that means 2 pi on n is equal to 8. So n is equal to 2 pi on 8, which is equal to 2 pi. No, it's not. It's equal to pi on 4. All right, so a is equal to 3 and n is equal to pi on 4. So your function is y equals 3 cos pi on 4t. All right, question 4. This time we've got a horizontal translation. So it does say plus epsilon. That does mean we've gone to the left in the negative direction, but because the graph of sine and cosine, they're repetitive and they repeat the same pattern. So you can go to the left and you could also go to the right and still be the same graph. Okay, it's a bit different to if you had a parabola. Say if you went to the left, that's not the same as going to the right, if that makes sense. Okay, so for this one, let's first of all do the amplitude because that's the easiest thing. So our amplitude is just a half. So I'm going to write that as a fraction because I prefer fractions, but you can write it as 0.5 if you like. We don't have to worry about the period. It's already done the period for us. So our period for this one is 2 pi, or our value of n is 1. Okay, so we don't have to work out that. We're just working out the value of a and epsilon. Okay, so when you think about your original sine graph, sorry, just had a bit of a blank, it would usually start at 0 and go like this. All right, so there's one, oops, I went too far. I was going to get rid of the whole thing. All right, just one full period that is there. So 2 pi. All right, so there's the yellow, it shows one full period. Now, you don't always have to start at the x-axis and end, but I'm just showing you that because then you can see how it's how it's shifted to the left or the right. So with your shift, we can see that it has gone across pi on 3. So your value of epsilon is equal to negative pi on 3. Now you could have very many different values of epsilon, okay, because your graph can shift even more, all right? And it can also go to the left or the right. So we can say epsilon is equal to negative pi on 3. But you could also have a positive value of epsilon. So if I was to say it went to the left, all right, I'm going to graph it. This is probably unnecessary, but it's good to get an understanding of what is actually happening. So our basic sine graph, I'm going to just draw it. I'm going to do 2 periods. Very poorly drawn graph, but basically this point here at pi on 3, it could move to the right, pi on 3, so that's why it's negative pi on 3, Or we could say this point here, okay, which is 2 pi, has gone to now pi on 3. All right, so the start of your graph was at 2 pi and now it's gone to pi on 3. So what's the difference between the two? So 2 pi minus pi on 3. So let's just change them to have the same denominator. So 5 pi on 3. All right, so if we've got a negative epsilon, it's negative pi on 3, means it's shifted to the right, pi on 3, or in the positive direction, pi on 3. Or we can say it's been shifted to the right, sorry, shifted to the left, pi on 3. So it's gone either that direction or in that direction. All right, let's have a look at question 6. So a function with the rule y equals a sine nt plus, I'm just going to call it e, has the following 3 properties. Okay, so we've got a range, -4 to 4. When I see range, it kind of tells me it's the amplitude. So we just got to be careful that it hasn't been shifted up or down. And I can see that it hasn't because it doesn't have anything here at the end. The period is 8, and when t equals 2, y equals 0. So that t equals 2, y equals 0 is telling us the x-intercept. So it's kind of helping us with the value of e or epsilon. All right, so a is easy. That's just your amplitude, which is 4. Okay, so I get that from the range. Your period, so 2 pi on n is equal to 8. So n is equal to pi on 4. And now with your graph, sorry, it's going to get tricky. Actually, I could probably do it a different way. Probably solve the equation instead of doing it graphically. Let's do it. Oh, actually, yeah, we'll do it that way. All right, so let's substitute what we know into the rule. So we've got, at the moment, y equals 4 sine pi on 4t plus epsilon. All right, I'm going to take that pi on 4 out. And when I do that, I've got to put a 4 there. All right, because when I expand that bracket, pi on 4 times 4 is going to give me 1e. All right, so let's substitute in t equals 2 and y equals 0. Oh, that's terrible handwriting. So we're going to have 0 equals 4 sine pi on 4. T is 2. All right, so we can solve that on the calculator. Just get the calculator up. Whoops. Okay, so 0 equals 4 sine, whoops, I've got the pi on 4. Actually, I'm going to put that here. Pi on 4, and then put another bracket. 2 plus, and I'm just going to use x. And, yeah, all right, and comma x. Now, let's see what we get if I might have a general solution. All right, so I did just in that previous one, I forgot a bracket. So I put that bracket in, and now I'm just, what I got here is the general solution. So I'm just going to change that to restrict the domain. So let's just go from 0. We're only going to 2 pi because that's one period. So All right, so x equals 2 and x equals 6. So that you can just see that you can have either shift. All right, so I'm just going to go with 2. So solve on CAS. So we're going to have, therefore, y is equal to 4 sine, get e equals 2 4 sine pi on 4 t plus 2. Now, actually, I just realized because it is in this form in the question, I probably should expand that bracket. So I might just go ahead and do that. So what's that going to do? Plus pi on 2. All right, let's have a look at this last one. So this time we've got a sine function. Sorry, I was meant to highlight that. And we have a range of 0 to 4. Now, when this is a good indication if you have a vertical translation. If your range is two different integers, like, one's not negative and one's, the same number, but you've got negative and positive, like we did before. So 0 to 4 tells me that we've been shifted up. Okay, and period of 6. And when t equals 1, y equals 3. All right, so this time we've got to find a and d and epsilon, which I might just start calling e. Okay, so a isn't as easy for this one. So if I was to graph this, our sine graph is going from 0 to 4. Now, graphing, I think, is sometimes easier to understand what is actually happening. So if I was to draw a line going through there, that is basically what has happened to your x-axis, okay? We've been shifted up because in your normal sine graph, it is split in half with your x-axis. So let me just go up to these ones. You can see the x-axis is the halfway point when you're not going up or down. So if we've gone up, I'm just going to go halfway between whatever my range is. So my range is from 0 to 4, so halfway is 2. So that means my amplitude, is 2, okay? So it's the difference between that halfway point. So it's 2, so your value of A is equal to 2. And you can see we've also been shifted up by 2. So that x-axis has been shifted up by 2. So D is equal to 2. All right, your period we do the same way as before. So 2 pi on 6. Oh, it's pouring with rain here and I don't skipped a step, sorry. 2 pi on n equals 6. So let's just switch n and 6. So 2 pi on 6, which is pi on 3. And the other one we need to do is the horizontal translation. And we get that by substituting in t equals 1 and y equals 3. So my equation at the moment is y equals a, which is 2, sine n, which is pi on 3, t plus epsilon plus 2. All right, so we're going to sub in t equals 1 and y equals 3. So I'm going to have 3 equals 2 sine. I'm going to take that. Actually, we don't need to take the pi on 3 out. If we were graphing it, it probably would, or if it told us that it had been translated, then we would need to take it out. But because we're just solving it, we don't need to, and we saw that in the previous example. Okay, so let's, oh, I just realized I didn't put the value of t in, so t is 1. If you wanted to, you could solve this by hand. So maybe let's solve this by hand. All right. So we're going to have 2 sine, I'm just going to shift sides. So pi on 3 plus e plus 2 equals 3. All right, so let's quickly solve. So we're going to divide both sides. Oh, no, sorry, let's get rid of that first. And then, I want to do a few things at once because otherwise we're going to be here forever. All right, so I've subtracted that 2, okay, and divided by 2. So when I rewrite, now you could have done that all in, you could have done that in 2 goes, but I'm just doing it in 1. All right, so 3 minus 2 is 1 divided by 2, so a half. All right, so take inverse sine of both sides. All right, so that's when you need to know your exact values. So sine 0.5 is pi on 6. Now I did actually have to pause the video, I confess, because I'm not the best with my exact values at the moment. All right, and I'm going to finish that off here. So epsilon equals pi on 6 minus pi on 3. So let's just change that to be the same denominator. So 2 pi on 6 is the same as pi on 3. So E is equal to negative pi on 6. So a bit of working out there. I might just do a summary here. So A is 2. Our period was 6, but N was pi on 3. D, our vertical translation was 2, and epsilon was negative pi on 6. Now, as I've said, because your sine and cosine graphs are infinite unless you have a restricted domain, so the value of epsilon can be many, or infinite values really, but that's just our first one, and then it would just repeat over and over again. Okay, bye.